Okay.
So today we're going to go over that Frigidaire Washer. Some of the questions were easy and some of them were a little bit more trickier than the dishwasher test. The first one, to enter in the test mode on the washer, you press how many buttons and what are they? So if we go to the tech data sheet and entering diagnostic mode, there's 3 buttons. And it's the press soak button, extra rinse button, and power button simultaneously. So you got to press all 3 at the same time to get into the diagnostic mode. Why do you think they make you press all 3 buttons? Why don't they make it easy?
So you can't accidentally do it.
So customers don't do it. Hold on a second. I'm going to turn the AC off only because the noise on the recording. Okay, sorry about that. But yeah, so sometimes, people complain that diagnostic mode is so hard to get into, but, all these different manufacturers are going to have different diagnostic modes, and they make it that hard because they don't want a customer to accidentally press 1 or 2 buttons and go into a diagnostic and do something to the machine they shouldn't be doing. When actually diagnostic, that really can't hurt the machine, but, they don't want to mess with that part of the machine. Okay, so that was the answer. Number 1 is 3 buttons. And let's go to the second question here. What must you do before entering the test cycle?
Empty the tub?
Yeah, and it says right here, no. Before entering the test mode, empty the washer. So in other words, well, if the machine's not working and it's filled with water like the washer you guys have tonight, you might want to go into test mode to force the pump to run, but this machine says don't do it while it's full of water. They don't explain, but run the spin cycle, open the service panel from the front side of the unit and drain all the water. So they want you to have the water out before you go into the test mode. I don't know the reasoning behind it, because if the machine's stuck full of water, you'd want to go into test mode and put it in the pump out to do that. But if the motor's not running, it doesn't matter. So that was the second question. Let's go to number 3.
So how would you empty it?
You'd have to either lower the drain hose to the ground if the machine will allow you and the water will just run out by gravity.
Okay.
Or get a cup and a bucket and you do this. I've done it many times.
Wow.
You don't have to get 100% of the water out, but you get as much as you can. What some people do, it speeds it up. Let's say the drain hose comes out of the back of the top of the washer. Let's take a look at that for a second, because this is some of the things that we could do. Give me a second to open up this program. I don't know if it's going to open that way. Okay, here it goes. We've had many ways. Back in the day, we didn't have all the tools that we have today. I mean, we had all kinds of different things. One of the things we did was we had like this little pump or impeller, and you connected it to your drill. And so you had 2 hoses. One hose you'd lay inside the washing machine, and the other hose you'd stick the drain of the customer's washer. Now, it wouldn't be as big as a washing machine hose, so it'd take a while, but you would turn your drill on, and the drill would run a little hand pump and suck the water out.
So
That's
can you use
smart.
a vacuum in it too?
Well, here's a problem with a vacuum. We could use a wet and dry vacuum to suck the water out. How big is our vacuum?
Not
About 4 or 5 gallons.
4 or
Some
5.
washers hold 30 or 40 gallons. So if you turn a vacuum on, the problem you got is that vacuum fills up real fast, and you got to stop before it overflows, and then you got to do it again. But a vacuum does help. Like in most washing machines, the drain hose comes out the bottom. So you have your tank, and the water goes to a pump, and right here, and then the drain hose goes to your drain pipe. If you just take this hose out of the drain pipe and lay it down, the water's going to run out. But most customers don't have a floor drain in their house to run that water into. So what you do is, hopefully you have a bucket or something, or your vacuum, and you lower it into that, and then gravity will feed it, and then when it fills up, you just raise it up again, dump it out, and then do it 2 or 3 times, and that'll speed it up. They had this thing, and I haven't seen it in years, but back in the 80s when I was doing it, we had this little piece that was plastic, and it went to a small hole here, and then there was another piece here, and you take an old fill hose from a washing machine and connect it to the wall where the cold water was. And you connect a fill hose to here with a hose clamp, and you would take another old fill hose, and you'd have to cut the end off so you could put it on there, and you take this and you would stick it in the drain pipe. And what would happen is it would shoot water from this opening into this other opening here, and as it did it, it would pull the water from the washing machine and create like a siphoning effect. So you'd lay this part in the washing machine at the bottom of the washer, and you turn on the customer's water in their house, and they would use the water from the house, and it would shoot a jet to the other hose, and it would pull the water from the machine and run it out the drain. Now, I haven't seen that in a long time, but that's how we got the water out. It would get it all. You'd leave a little bit of water at the bottom of the tank like that, but that would work. So another thing that we used to do is if it was like a drain hose that came out real high on the top of the machine and went here, if you lay it down on the ground, the water's not going to run out because the water in the machine isn't that high. So you could actually take a drain hose from a washing machine, coil it up, lay it down in, fill it up with water, and what I do is I put my hand over one end. So it holds that water in there. Have you ever taken like a straw and put it in a drink cup, and like put your thumb on it and you pick it up and the straw holds the water? You do the same thing with like an old drain hose. You keep a real long hose in your truck, and we had one like 20 feet long. We'd coil it up and lay it down in the washing machine so it filled up with water. Put your hand on one end, like seal it up, hold that end, take it outside the machine, and we'd run it, like if it was in a garage or something, outside the garage to the grass, we'd lay it on the ground. As that water fell out, it would actually create a siphon. If you couldn't do that, you could take your vacuum, put your vacuum on the end of the hose, leave the other end of the washing machine, turn the vacuum on, and as it sucks the water out, it'll create a vacuum. Then just pull your vacuum pump out and throw the hose on the ground, and then the water will just all pull out by gravity. So you just take a hose, stick it in here, lay it in the yard outside the door of the house, in the garage or whatever. Take your vacuum cleaner, your wet and dry vac, suck it. As soon as the water starts to flow, you just pull that hose out and the water will just gravity feed right out. So there are many ways to do it. Okay? You can take an old like Frigidaire drain pump, put 110 volts to it, use it to pump the water out to the customer's drain. Many ways will work. So that's what must you do before a test cycle. Now, the main motor has how many windings? Let's go ahead and look at the schematic here. The main motor here, we go to the diagram. Right here. Here's the main motor right here. How many windings do we have?
3.
2.
2.
There's only 2 of them. That was a good catch. Inside the motor here.
What's that?
Now watch this. This motor changes direction that it runs. Okay? On some washing machines, they have a transmission. The motor only goes one direction, but it creates agitation by moving gears in a transmission. This machine doesn't have a mechanical transmission, so it can't take something that rotates in a circular motion and make it agitate. Well, then how do they make it agitate? They actually run the motor and stop it, then run the motor the other way and start it. Well, how do they do that with this motor? How do you think they do that? How do they make the motor go one way then the other way?
I remember we did that with
They
the
do
washing
that in a
machine.
BMW washer.
Yes, when we flip it, when we flip the terminals, it would actually turn the other way.
Sort of. I don't know if you guys remember the BMW washer, but it had a CW and a CCW winding, a clockwise and a counterclockwise winding. So what happens is they only energize one leg, and so when the power comes here, it goes through this winding and goes to neutral, and then it comes through here and feeds the other winding. By doing that, one of them is the main winding, the other one's just like a start winding, and it runs one direction. When they turn the power off, they run the power through the other winding like this, and it goes across through this capacitor and feeds the other winding the other direction. That changes the direction of the motor by which winding they put the main power from. So that's what they don't put power to both plugs at the same time to make the motor work. They either energize one or the other, and that's what tells the motor which way to go. So they energize one, the motor goes one way, then they stop, energize the other, and change the direction of the motor. And that's how they create agitation. To create spin, they just turn one of them on and the motor runs. Yes?
Isn't this motor 240 volts?
No, sir, because we are only a 110 volt washing machine. Where are you going to get the 240 volts from?
Oh, no, you're right.
This is 50 to 70 microfarads. That's the capacitor there. And then that's 3 to 5 ohms.
Okay.
Okay? And that's where I got some of you guys on some of the questions here. So, if you were to test, the typo, I told you guys to tell me if you saw a typo, right? To fix that. If you were to test the resistance of the motor from the control board, what connector on the main board would you use, and what reading should you get? Well,
1 and
1 and 2. What do you mean 1 and 2?
2.
CNA.
The one on the left.
CN8 1 and CN8 2.
Yeah.
Okay, so that would test through both windings, right?
You gotta connect it to neutral. Right?
Well, you got to connect it to neutral. That would be the power cord, right?
Yeah.
Well, let me give you a little answer to one of the other questions, and we'll come right back to that because I will give you that answer. But I want you to see this question first. I think it was the last one. There's an error in the wiring diagram provided from Frigidaire. Here is the model number. A two-part question, no partial credit. You either get it right or you get it wrong. I think I did give you partial credit one. I gotta take it away now. What is the error and how could you prove it? Well, if you went to the B2B website, the Frigidaire one I gave you on the dishwasher lecture, instead of this tech data sheet that we have here, we have a schematic, a parts breakdown, but it has a schematic. Let's go to the schematic for a second. And on the schematic here, you see this black and white wire. Not only does the white wire feed all these components, but the white wire also goes to the connector on the board where the black one goes. It's showing you both the black and the white here. Now, if you look at the other diagram, which was in the tech data sheet, here's the power cord. This is the black wire coming in, line 1, and this feeds all these relays on the board. The neutral wire goes to the components. Then they're supposed to have a neutral wire coming here to here on the board.
I saw that, but I thought, I said, well, that couldn't be the answer. I was like,
but if you would have went to B2B and one went, and one was like close. One.
It's the only thing I could stare at that stood out.
But it was good that you went to B2B to try to find additional information. And you found the other diagram. You had it open.
I did.
It wasn't provided to you. But the manufacturer just drew it wrong or forgot to add that line onto that tech data sheet. I didn't realize it until I pulled that tech data sheet and was writing up the test. I said, how do you check that motor? And technically, to check the motor, you would go from here to here, and that would check this winding. But what would happen is it would go this way and put them two in parallel, so it would actually drop the resistance. To check 3 to 5 ohms, you have to actually go right to the motor to get that 3 to 5 ohm reading. Now, you would check from here to here to check this winding, and you'd go from here to here to check the other one, and yes, you should have 3 to 5 ohms. But if you went from connector A and went to these two, what would you be testing?
The motor?
Those two in series. So if each one was 3 to 5 ohms individually, and you put the two windings in series, you should have between 6 and 10 ohms. So for you guys putting 3 to 5 ohms, I marked it wrong. Because a lot of people said they would use connector A, or some people just said pin 1 and 2. I knew what they were talking about, but if you're going to tell me connector and I talked to you on the phone and said check pin 1 and 2. Now I got a 1 and 2 here, I got a 1 and 2 here, I got a 1 and 2 here, I have a 1 and 2 here, I have a 1 and 2 here. Which 1 and 2 am I telling you to test?
Yeah, right.
CNA.
I have C and A. But if I don't give you that information, you might question it. And if you don't have this diagram here, I say just check pin 1 and 2, and you should have about 6 or 10 ohms. You're like, okay, I see 10 1 and 2s. You need the connector. So you need CN is connector, 8 is connector number 8, 1 and 2 is pin 1 on that connector, and pin 2 on that connector. Like this one here has a pin 1 through 7. So it tells you which pin to test. Okay? So when you're talking to somebody, say, I checked from pin 1 and 2 on CN8, and I got 6 ohms, that's telling me the windings are good. But if I'm checking voltage, I want to go from here to here, because this one is supposed to be neutral, and this one is line 1, and it's coming from here. It's coming from some relay on the board. That power's coming into the main board here, feeding all these components and feeding the board, and then going through the connector and through that particular winding. Okay? So a lot of people said they will put both meter leads here, but then you should have that double, 6 to 10 ohms. Okay? And then, if we want to be technical, this here is a cross, so you're actually reading this in parallel, you might get a crazy reading. That's why if you want to check ohms on this motor, you can do a quick test from there, but you might not get a reading you expect. To get the exact 3 to 5 ohms, you're going to have to go down to the motor on this washer, and you're going to have to check here and here and here and here to get that 3 to 5. If you check from here to here, you're reading through this, but you also have that in the circuit. So that could give you a bad reading with that capacitor on there. All right? But it would be a good voltage test to make to see if the board's sending power down to my motor. If I'm getting 120 volts in any one of those pins, what does that mean?
Good.
The motor's not running, I got 120 volts, the problem's got to be at the motor.
And the motor itself.
Either the motor's physically jammed up, belt's broken, not turning, or the motor's bad. I don't need to ohm it out. A lot of times when you're troubleshooting something, ohms is not always the best test. I tell people always check voltage first to make sure that component has voltage. The only time I don't want you to check voltage is if it's a safety issue, like a microwave of 4,000 volts, or you're checking voltage to a motor and it's got a belt and everything running, and where the wires are, maybe you can't get your hand immediately in there because you got motor and pulleys in your way that you could get hurt from trying to stick your hand in there. Then don't do that. Then let's go to ohms. But we can check voltage at the board at least and say, okay, the board's sending power. Any questions on that one? No? Okay. Let's go to the next question. That was, what does the retractor do in the washer? So I went ahead and downloaded, somewhere I had the parts breakdown.
If only I didn't have to answer.
Where did I have that parts breakdown? Let's just reopen it. I don't know where it
didn't
is.
have to answer the questions. I messed up so much.
So if you guys remember the B2B website while you're taking the test, you're going to say, well, what the heck is a retractor? I've never seen the retractor. If we went to the parts breakdown, and we see these components, number 49 right here is the retractor. I don't know why they put the word drain pump, because I don't think it really has anything to do with the drain pump. Because if you look, we have a different part number here for the drain pump.
Could it possibly have two drain pumps in it?
No.
What was
So-
the other one?
This one here is the drain pump. This is obviously the drain pump. It's got hose connections. Do you see any place to connect the hose to that part?
No.
No.
Now I tried online, checked a couple different sites, Marconi and a bunch of the others. I couldn't find a physical picture of that part, or otherwise I'd show you what it looks like. But I told people, they didn't know what retractor means, but you know, if a writer wrote a story about a football player in the news and it wasn't true, what do they have to do?
Retract it.
What does that mean to retract it?
Take it back.
To take it back. Okay, so if you know what retract means, to take that statement back, if I'm calling this part a retractor, it means it's moving something backwards, or it's moving something, right? So no, what actually happens is if you see these two parts are connected together. This is like a little motorized device, and it's connected to this lever, and this lever goes to the gears down here on this pulley. And when it engages with the pulley, it's the spin cycle. When it disengages, it's the agitation. We have an outer shaft and an inner shaft. The inner shaft is for agitation, and the outer shaft is for spin.
So the retractor control the agitation?
The retractor moves this lever, and this lever either engages both pieces, so both of them spin, or disengages or retracts it away from the pulley, so only the center shaft works and allows it to do what we call agitation. It's called shifting motor on other manufacturers, or actuator motor. Just each manufacturer calls it a different name. Okay?
So why is it called a retractor?
Because that's what the manufacturer decided to call it. Why do you have your name? Because that's what your parents decided to call you.
I understand, but it made more sense to be called shift.
Yeah, but that's the name another manufacturer uses.
Oh, okay.
So it's retracting the piece also, isn't it? It's just the engineer who designed it said that's retracting the gear, and we'll call it a retractor.
Back to its
And when it got built, guess what? It was called a retractor.
Okay.
We have no option there. If you don't call it by the name and you try to order the part, your parts department won't order the right one if you don't give it the right name.
Right.
So on Frigidaire said, I need the retractor. On Whirlpool, I need the actuator motor or the shifter motor. That's just how they do it. Okay? So if we go to the next question, how much voltage is supplied to the wash motor, and what two terminals would you make the test? And I just showed you that. It would be CN8-1 and CN1-2, or CN8-2 and CN1-2. This is neutral. Why am I testing 2 and not 1 to here? Why am I testing this one and not this one and this one?
Because that one is live, and okay. Number 2 on CN.
Well, how do I know these two are line 1 or neutral? How do I know what they are?
Following on the diagram.
You can't follow them on the diagram. There's nothing showing you.
True.
You don't see any connections. You see a box with 2 wires. And if we looked at the other diagram, that shows even less information, right? If we look at this diagram here, and we're looking at the motor, we see these 2 lines coming in. Heck, how do I know if neutral's going here or line 1's going here? How do you know?
You said neutral's the white wire, right?
Yes.
Yeah.
And the white wire is feeding, neutral's feeding into these lines already.
And we're into what lines?
Into your red, or is it red and pink? Right?
I don't know. What are you talking about?
The
That's
lines you're
red.
following.
That's blue. That's black. That's black. I'm sorry. That's red and black.
Red and black? Okay, so neutral's
Both
already
of them.
supplying power to the red and black wires.
No, it's not. Neutral.
Through the motor.
The neutral's going directly into the motor here. So if I got neutral on this side, what's got to be on this side?
Live on live.
Line 1.
On line 1.
So I got to have line 1 come into here or here. If I already have neutral here, I'm not going to put another neutral. If I put 2 neutrals to the part, it's not going to work.
So the neutral is basically like voltage.
The neutral's connected to everything. If you look at your outlet, you have a line 1 or neutral. The line 1's a small or neutral. I'm already putting neutral to this motor. If I tell you to put that motor on the bench and run it, and I already got neutral connected, what are you going to connect?
The line.
So you're gonna take the line 1 and connect it to the other one, right? Neutral's already connected here. I'm not gonna run another neutral, so the way this works is the line 1 is coming in. Then why do I have a neutral on the board then if I don't need it? Because if we look at this diagram, hold on 1 second now. If we look at this diagram, I got neutral to the motor, to the retractor, to the pump, to the cold water valve, to the hot water valve, to the detergent, to the softener. I already got neutral going to all these parts. That means all these are what? Line 1. Very good.
Line 1.
So why have a neutral go to the board then? Because the neutral is not going to any of them parts.
So because you have all your switches on the
Is
other
it for
end and the
safety?
Sensors. No.
What's that symbol?
Resist.
I'll draw a
Relay?
little bit clearer for you guys because obviously you can't.
Transform.
It's a
no,
transformer. So in other words, those two are feeding power to the board. Probably have some sort of transformer on there dropping it to lower voltage so the board works. But we have to feed power to the board. I can't make the board work with just one wire. So the board is a component like all these, so it's got a neutral also. But the only thing is that this line 1 is going like this to all these relays, and I got a relay switch here. If I close this relay, then I'm turning the pump on. If I close this relay, I'm running the motor. If I turn this relay on, I'm running the extractor. So line 1's coming into the board, and you say, well, I don't see that. I'm just seeing a big box. A lot of stuff is not always cut and dry. This is where like you have to learn. This is how it is. If I got neutral on all these parts, then obviously the other side's got to be power coming into them. I can't have two neutrals to make a part work. You have to have one black wire and one white wire to make that part work. I already got the white wire going to all of them here. In this case, it's written blue, but it changes to white. But the other ones are power coming in. That is something or assumption you have to make when you're looking at it. This one here is just as vague as the other one. You look at this one, and how do you know? Let me erase this. How do you know? Well, if I look at all these, all of them are going to neutral, and power's coming in here, so it must be power going to here, here, and to all these relays. All these relays going to those parts, but power's coming in there feeding those relays.
I think that's why I thought the retractor was, on my answer for the retractor, was that it provided power to the board.
But it
it's
doesn't.
One single plug. No, I know it doesn't. Now that we've gone over it, I know it doesn't. But it's because the one connector on this diagram is separate from everything else. But then
It's probably because of the logic of the board. Because maybe it requires a little bit bigger relay. They either use relays, which is a switch with a magnetic coil, and you could put low voltage here, like 5 volts, and you could have 120 on the switch, so when the switch closes, it sends power to the retractor or the motor. That's why if you notice the motor and the retractor are running off of separate plugs in all the water valves. Maybe the water valves don't draw so much amperage, so to cut down on putting bigger relays on the board, they want to make these boards as small and compact as possible. Why? Because it costs money to make them, right? So instead of using a relay, they use something called an SCR. And an SCR is 2 diodes, like this, one facing one way, one facing the other way, and you're like, well, wait a minute, if I have a diode, that means the arrow's pointing to a wall, current can't flow this way. Well, current can flow that way, okay. But then if I put another arrow over here and put a wall this way, let me take this line off like this, now I got 2 arrows pointing to 2 walls, that means no power is going to get through either way. But what the SCR is, and the name is silicon control rectifier. Rectifier is another word for diode. They have a 3rd wire connected like this, and a low voltage signal from the computer board goes here, and it closes a switch, an electronic switch. It's not like a physical piece of metal that opens and closes. It actually just bypasses those diodes and allows current to flow through. When I stop sending that signal, it opens back up and it blocks flow. But SCRs can't handle high amperage draws usually. So the amperage draw here is not as high, and these water valves don't draw as much amperage. The resistance is really high, where these resistance are low. This one's not that low, but the retractor is probably because of its size and the amount of current flowing through it, that it's not going to be run off of an SCR. It's probably going to be run off of a relay. And I'm only guessing that because I haven't really seen the board. But if you look at the board, you'll probably see two big box relays here. Or this might have three. It might have one for one direction, one the other. And then these are just little tiny little circuits like this that are allowing current to go through. You won't see those big plastic boxes that are like soldered onto the board like most machines. So, what buttons would you press to show the frequency of the water level sensor? And if I gotta erase all this again. Look at that, isn't that cool?
That is cool.
So you would press these three to get into the test mode, but what I was really looking for is you press the temperature button and it'll show the display.
It's only 4.
What?
It's only 4 buttons.
Well, yeah, if you put just temp, I accept it. If you say you press these three, then press temp, I accepted that as well. Okay, I was really looking for temp because these three are the same as the other three for diagnostic. But if we follow the note, after you do that, the normal and the spin signals on the display. So you're going to look at the display, and it's going to have numbers on there, and the display will show the middle number of the current frequency. So if this was the frequency 2235, it's only going to show the middle number, which would be 23. So you'll have a 2 and a 3. What would this one be right here? 4 and 9. And that would be the frequency. So the next question said you had what? 32. So that's this one, 23.20, and then that should be about to have 11 plus or minus half an inch. So it might have 10.5 to 11.5 inches of water inside the tub.
The frequency is like level out, right?
No, the water level switches back in the day were just an open and closed switch. The switch made connection when there was no water in there, and when a machine filled up with water, a little rubber disc would flip the switch and shut the water off. Mm-hmm. Well, this is not a switch. It actually changes frequency. So what happens, a little piece moves up and down, and where it makes connection like this, it changes the frequency of the voltage flowing through it. It's like
so
a
it can slow
converter.
it down a little bit to the point where it can.
No, frequency, it's still hard to explain right now, and I'm not going to get into the whole thing right now, but frequency is like the pulse of electrical current.
Okay.
And it can pulse faster or pulse slower, or big pulses or little pulses of electrical current. So as the water level changes, that frequency will change because this piece is moving up and down on a scale. And when it hits here, it changes the frequency of electricity flowing through it, and the board's reading that. Mm-hmm. Okay? So that other question was 11.5 inches. It said, what was the number? 32, I just showed you, and it was 11.5 inches, so that's the answer number 8. Number 9, as the water level in the washer goes up, the frequency goes down. So, and how do we figure that out? Well, if we can look at the bottom two, which is empty, and the maximum number, it's 26 frequency high, and then when the machine's full of water, it drops to a frequency of 20, it dropped down. But you can see as the water level increases, this frequency number decreases. Yeah. Okay, so you have to actually have a digital meter that reads Hz, which is hertz, and you can put it on the washer pressure switch, or in this case the washer pressure frequency device, and you can watch as the water's coming in, the frequency change. The LG washer and some of the other washers also use a frequency type of switch, not the Whirlpool Duet though. But you could actually measure the frequency as it's filling, see what the frequency is, and as the water level changes, you could measure the frequency. Okay? Why would you want to measure the frequency, by the way? Why do you want to know frequency? Water in the machine.
So it doesn't short the board? No.
Not that don't short the board, but for accuracy, what's one thing customer will call you besides water not filling up? What would they say about the water? What kind of complaint would a customer give you?
Won't drain.
It doesn't fill
Not
enough.
enough water.
It's not enough water in the machine. And then you're going to have to say, well, I take a ruler and stick it in there and say, I got 10 inches of water and I got a frequency between 23.8, 23.2. It's fine. It's working fine, man. This is how much water is supposed to be in here. I can't do nothing. But otherwise, what happens is technicians don't know how to make that test, and they'll go, oh, it's not enough water. Yeah, you're right. There's not enough water. It's only like this high inside the machine. I'm going to order your water level switch and a water valve. They just go order anything. And they come back and they change them both, and the customer's still complaining it's not full of water. There's nothing wrong with the machine. Okay? But the first technician already started changing parts in the customer's head. Yeah, there's something wrong. But if you went, man, according to this much water, I should have this frequency on the switch, and it's matching up. There's nothing wrong with these components. It's doing what it's supposed to do. The maximum amount of water you're going to get inside this machine is going to be about 20 inches of water. That's almost 2 feet. 21 inches. That's not a lot of water. Most machines used to fill up like this high, like
All the
2
way.
feet of water. And nowadays manufacturers are told by the government use less water, less voltage. Have anybody seen Donald Trump is trying to say that he's going to tell these manufacturers to cut that junk out and go back to washing machines the way they're supposed to wash with full water? That was in the news the other day. That, you know, the government's trying to save electricity and save water. But he's saying, look, these machines ain't working right the way they are. If you check the news, do some research. He was actually trying to get the government to stop telling manufacturers to try to cut back on water and electrical consumption. Let these machines wash clothes, because people walk around with dirty clothes. I'm not saying he's right or wrong. I like the machines that use more water because, listen, if you got something that's dirty, and you stick it in a bucket that's only half full, a bucket that's totally full, the lesser water can only hold so much dirt.
Exactly.
So the only way to get those clothes clean is to put half the amount of clothes in that you would a full washer. That means now a bigger washer that did a big load of clothes, now you got to do 2 loads of smaller. Aren't you using the same amount of water?
Technically.
But the machine, as it washes, uses less water per load. You just got to do twice the amount of loads because you can't wash the same amount of clothes in that cycle. Make sense? All right, so that's the washing machine. I'll post this video up later. I'm not going to post it up right away. So if you guys want, I'll make a copy of it. You guys can watch it again in another time. Any questions? No? Okay. I just
I
finished
finished.
my-
I just want to let you know I'm done.
Okay. You don't need anything?